Hello and welcome to day 8 of Advent of Code 2024. So this day is called Resonant Collinearity. And this problem is about identifying what's called the antinodes. So this example input here defines antennas, and what we are going to find is actually something called antinodes, and the antennas is of the same frequency if they have the same char, basically. And antinodes are so for two antennas with the same frequency, we have two antinodes on either side of them. So the point of this part one example here is to count the number of unique locations that contains an antinode, but only unique locations within the map that contains an antinode. So let's jump into the code. So we begin with reading in our input file. We call that map. Okay, so to be able to identify the antennas of the same frequency, we're going to put them in a dictionary. It will be the char of the antenna and also the X and Y position of the antenna. Or actually it will be, as we are collecting antennas of the same frequency, we will obviously have the list of the positions of the antennas of that frequency. So just a little bit just for time constraint here, we will I'm just gonna pause the video here quickly. Yeah, just to save some time here, I just pasted in some code from my original solution, just to speed things up here. So we just add all the positions within the map. That's not an empty space. It's an antenna, but we will also check if that so that we only collect antennas of the same. So our dictionary will be the antenna type, basically containing all those positions that antenna type or that antenna with that frequency exists on. So we want to collect unique antinodes for these antennas. So we use an hash set, so we want to go through these antennas by the frequency. So we can do that by looping through the antenna dictionary by its values. So we have so we can call it antenna range in we will have our antenna range. So within that, we will just for it. So for antenna range count, just to be able to get the pairs, we will do for count. So just to exclude when we are on the same, we just do simple continue down. So we get the pair. And so an antinode is so we're gonna put an antinode on each side of each antenna, and the distance is the distance we are going to put on it is the antenna's x range, the antenna 1's x minus the antenna 2's x multiplied by 2, and the antenna 1's y minus the antenna 2's y multiplied by 2, and also the opposite to be added to the other side. So that kind of that is, oh yeah, sorry, going ahead of myself here. Yeah, so that is the only code that we need to add. So now what we have done here, we have added an antinodes on either side of each of these two antennas. So basically what we are going to do here is just add our part 1 text here. So the last thing we need to do here is actually filtering out all the antinodes that are not on the map, because this logic will add antinodes that are not visible on the map. So we add our visible this will be our antinodes where the position start with y. Position y is greater than 0, greater than equals to 0, and assertion y is less than the map count, map row count, and the position x is greater than equals to 0, x is greater than the map row length. So now we're just going to add the visible antinodes count, and when we run this, we should see the value 14 as the part 1 answer, and that is correct. Okay, so let's see here. Part 2 here is now we see that, well, we should not only add antinodes at 2 points adjacent to each antenna. That what they see here is that the antinodes continue on with equal distances out from an antenna. So that will be our part 2 problem, basically. So running this example, we should get 34 antinodes when adding this one, and this is actually not that complicated when doing this, because obviously you could do it like you could go like down one direction and then go the other direction as well, but it will actually not matter. It's actually sufficient to go just by one direction, because the unique positions will be the same either way. So I did it like what we can do is actually just extend our logic. We can do it in the same loop. We don't have to add a new loop. So let's just call this antinode part 1, just to keep them apart. Yeah, so now we create an antinode part 2 as well. So what we need to do is we need to find the direction, the distance y, and the distance x of the distances of the antennas that we have found. So the distance y will be the antenna 2y minus antenna 1y, yeah, and the dx will be the antenna 2x minus 1 minus the antenna 1x, yeah. So we initialize the x as the starting point for the antenna and the y starting point. So what we're going to do is we are actually just going to go go until we reach the end of the map, just adding antinodes at those direction, adding those directions, those distances. I mean, so at those distances we're going to add antinodes all the way up until we reach the end of the map. So we do that by a while loop. Sorry. Greater than equal to 0, I mean, and that's the map count. Quiet, quiet. Well, that was my dogs. Yeah, sorry about that. So what we basically now is we just add those antinodes to our antinodes set, which is going to be the XY. Then we move forward in that direction by these direction markers. So we have our X plus C plus equals X and Y plus equals dy. So that's basically it. So if we run this, we have our part 2, we will so if we run the count on those, we should get our 34 answer. So yeah, so that's basically what I mean by, but obviously you can do it like that you can add 2 while loops and then just add minus equals instead, going the other way, going into the other direction, but it won't matter because the hash set will only add unique locations, and the locations will basically be the same, and the count will be the same. So you only have to go in one direction because yeah, it will be the same. So that was it for my this day for day 8. So let's see each other again at day 9.